6 times 8 is 48. So you multiply the numbers together, and then you multiply the letters together. So the constants are multiplied together, so 8 times 6 is 48. It's negative 8, actually, so it's negative 48. And x, there's only one of them, so that's x. Here, multiply this all the way through. Minus 3 times all these terms, minus 3x squared, plus 12x minus 15. Okay, can't do anything with these. It can't go any further. It's fully simplified, so you're done. Finally, the last one here, very similar to the one above it, minus 3y, and then minus negative times a negative 8. The size is 18, but negative times a negative is plus. So that's how you do those. Over here, you're gonna combine the last two questions together. So in question number 4, in A, you'll go minus 4 times x squared is minus 4x squared. Minus 4 times minus 4 is plus 16. Then I have 3 times x squared is plus 3x squared, and 3 times 7 is plus 21. Collect like terms, I have constants and I have variables. And if I'm careful, I notice that the x squared, there's x squareds, and there's minus 4x squared, and there's plus 3x squared. So together that gives me negative 1x squared, or just negative x squared. For the constants, I have plus 16, and then I have plus 21. And I add those together and I get plus 37. Okay, so I collected like terms. I have x squared. I can collect those. These are constants, or just regular old numbers. If I had 16 and 21, you add them together to get 37. Just make a little break here. 3x times x is 3x squared minus 21x. Okay, minus 7 times 3x, or 3x times minus 7 is minus 21x. Minus 2x times x is minus 2x squared, and then that's minus 8x. Collect like terms. X squared, I have 3, I have minus 2. That means I have 1x squared when I'm all said and done, or just x squared. Here I have negative 21x, I have negative 8x. Together that's minus 29x. Okay, so 2 marks, 3 marks for that question also. Want to go on to exponents. Some people had problems with this one. Exponent laws are important to be followed here. 12 divided by 3 is negative 4. And then I have m to the 4 divided by m. So that's m cubed. Okay, subtract when you're subtract the powers when you divide. So when you have two terms and you're dividing them, and so I have m to the 4 over m. So that's m to the 4 divided by m to the power of 1. 4 subtract 1 is 3. 5 subtract 4 is 1. So I'm done. Okay. Here I have 2x to the power of 4. So that's 2x times 2x times 2x times 2x. That's one way to look at it. Okay. Another way to look at it is this is 2 to the power of 4, x to the power of 4. Either way, you get 2, 4, 8, 16, x to the power of 4. Here, the negative, if you were watching what we did earlier on in the year in the course, the negative means this final answer will be negative. So whatever happens without the negative, so if we just ignore the negative for a bit, we'll do 2x squared all cubed, and we'll figure out that's 2 cubed, which is 8, and x squared cubed, well, power of a power means you multiply, power of power means you multiply these two numbers, so it'll be x to the power of 2 times 3, which is 6, and then here I have 2 times 2 times 2, which is 8, and the whole thing is negative because the negative is in front of the bracket. So anytime you have a negative in front of the bracket, your final answer is negative. Here I'm going to multiply. 5 times negative 7 is negative 35, and then because I'm multiplying, when I look at, that's a negative 35, sorry. When I look at my variables a, b, and c, I will add the exponents. So here I have 1, here I have none. So I'm left with a 1a. Here I have 2 b's, I have 4 b's. I add them together to get 6 b's. There's c, there's one more c, and together I have 2. So that's my answer. You could also just write that with an a with no exponent on top, because a by itself is equal to a to the 1. Okay, it's probably a little nicer without the 1, but it doesn't matter. BEDMAS says that you have to take care of the exponent first, so I'll square it 3x squared, and I'll get 9x to the 4. So it's 3 squared. X squared to the power of 2 is x to the 2 to the 2. Multiply the 2 and the 2 to get this 4 here. Then I have 4 times 9 is 36, x to the 4. So those are your exponent rules. Write a polynomial that's a trinomial that has a coefficient 3 and 4. Coefficients 3 and 4 and a variable x, so and a constant 7. So this is a tough one. A lot of 2 out of 3s here. So coefficients would be 3x and then this and then this, and a lot of people did this. But the problem with this is here are 3 terms on a trinomial, right? 3x plus 4x plus 7, that is a trinomial. But the issue is this is great, kind of. This isn't fully simplified. So if I had this as a polynomial, I'd have 3x plus 4x, I'd put those together and I get 7x. So if I had 7x plus 7, that's a binomial. So I have to change this a little bit so I can do this. 3x squared plus 4x. Okay, a bit of a tricky question. Let statements, let 7 less than a number is 4. So for all these, we'll say let x represent the number, and then 7 less than the number is 4. So 7 less than the number is 4. X minus 7 is equal to 4. 14 plus half his wage is 18. So let W represent his wage. And hopefully your writing is a little nicer than mine. 14 plus half his wage is equal to 18. Triple the cost is $27. So let C, and you could do X for everything. Let C represent the cost. Triple the cost, so 3 times the cost is equal to 27. So 1 mark for each of these. And we'll keep going to this page here. So now we're going to solve. We're going to figure out what K is in this question. So you collect like terms and then solve. I have 6K plus 7 is equal to 21 minus K. I bring my letters to one side. I'll bring them to the left side. There's 6K. When I bring this across, it was subtracting on that side. It'll have to add to come across. And then when I bring the 7 across, it was adding on that side. It'll have to subtract when you bring it across. So then I have 7K is equal to 14. And then I have 7K is equal to 14. And then what I want to do is get rid of the 7, and it's multiplying this side. So what you're going to do is divide by 7 when you bring it across. So K is 2. You can go back and check on this one if you want. So this was one of the checks you'll see that you're required to do later. If you go like this, left side is equal to this. 21 minus 2, that's 12 plus 7 is equal to 19. 19 is equal to 19. And that's the left side, right side check. This one's a little bit longer, a little bit harder. On the left, don't put an equal sign here. I know usually when you go down line by line, you say this is equal, this is equal, this is equal. But the problem is now you have a bunch of equal signs. Especially in the next question, let's try to keep it clean. And I'm going to expand the first bracket. 2 times x is 2x. 2 times 1 is 2. And then I have 2 times x is 2x. 2 times negative 2 is negative 4. Equal sign, 3x minus 9 plus 4. So now I have a bunch of x's and a bunch of constants. You might want to clean up each side first. So you might want to collect terms on each side before you start bringing things across equal sign. And there's nothing wrong with that. So if I have 2x and I have 2x on the left, I have 4x. If I have plus 2 and I have minus 4, I have minus 2. Over here I have 3x, that's the only x I have. And I have minus 9 plus 4, that's minus 5. So now I have 4x minus 2 is equal to 3x minus 5. Same as above, bring my x's on one side. When I bring that 3x across, I have to change the sign. And then when I bring this negative 2 across, I have to change the sign. So now I'm left with 4x minus 3x, which is x, minus 5 plus 2, which is negative 3. Okay, next question, which is pretty difficult. You want to get rid of a fraction here. There's a fraction built into the entire equation. I got a 3 and a 6. You want to multiply everything by the lowest common multiple of 3 and 6. So what's the lowest number that 3 and 6 go into? And the answer is 6. They both go into 6. So you multiply the first term by 6. And you multiply everything by 6. So this by 6. This by 6. And this by 6. So you notice here, I wrote the negative is left here. Okay, so it's going to be negative 9 times 6. So I wrote negative 6 times 9. It's the same thing. So 6 times 1/3 x is going to be 6/3 x, which is 2x. Okay, 6/3 x turns into 2x when you simplify. 6 times 12 is 72. So here I have 30 over 6, or I realize that I'm multiplying 5 by 6 and I'm dividing 5 by 6, and I end up with 5. So it's 30 over 6, which is 5, and this is 54. 6 times 9, negative 54. So I have constants on one side and variables on the other. I can bring my x's on the left, or I can bring them to the right. I like to bring them to where they're positive. So what I'll do here is I'll leave the 72 on this side, and I'll bring this minus 54 across. And when I do that, that becomes plus 54. The 5x was already here, so I don't have to change this sign, but when I bring this across, I have to make a negative 2x. I do that so that I end up with a positive number on the right here. I get 3x instead of dealing with negatives. And when I add 72 and 54, I get 126. Dividing both sides by 3, I find out that 42 is x. And that